5, they are the columns. They are the columns. So this is a matrix of 3 by 2. So when I say 3 by 2, I mean matrix of 3 rows and 2 columns. Sorry, 2 by 3 rather. 2 rows and 3 columns. 2 rows and 3 columns. I've taught you how to identify the rows. So the rows are your horizontal. So if you know your graph, your x-axis, so if you can just take your pen now and just do the cross, your Cartesian plane on which your graph is done. So that place where you have your x-axis, that's your row. That's how your row is. Then that your y-axis is example of your column. So vertical is your column, then horizontally is your row. So and we have what we call order of matrix. So order of matrix has to do with how matrices are arranged. So this particular one here is a 2 by 3 matrix, like I said already. The second illustration here is a 2 by 2 matrix. So it has 2 rows and 2 columns. 2 rows and 2 columns. 2 rows and 2 columns. You can see this particular matrix has 2 rows and 3 columns. 2 rows and 3 columns. So we have a matrix of 3 by 3 as well. 3 rows, 3 columns. We have a matrix of 3 by 2. 3 rows, 2 columns. Understand? So it's depending on whatever matrix you have. So every matrix has its order. Every matrix has its order. But this one we have the order is 2 rows, 3 columns. And the other one is 2 rows, 2 columns. So, the rectangular arrangement of what? Numbers. So matrices have wide application in engineering, physics, economics, and statistics, and as well in various branches of mathematics. Matrices also have important application in computer graphs, where they have been used to represent rotations and other transformations of images. So what they are simply telling us here is that what the application of matrix cannot be overemphasized. Like, its application is wide, like it has application in major branches. Major branches. So you see now we have types of matrices. Matrix rather. Matrix is singular. Matrix is singular. Matrices is what? Well, so type of matrices. Now you see the first one, row matrix. Row matrix. So it's only a matrix that contains just row. It's a matrix that contains just row. You see the second one, column matrix. Column matrix is a matrix that contains just columns alone. See the other one, rectangular matrix. Rectangular matrix. You can see it's a 3 by 2 matrix in a rectangular form. That's a rectangular matrix. Now, number 4, square matrix. Now, what's a square matrix? It's very important to know that a square matrix is a matrix that has the same order. A square matrix is a matrix that has the same order. The square matrix, the matrix that has the same order. So you can see the order of this number 4, the square matrix is called 3 by 3. So it is order 3 by 3 matrix. Order 3 by 3 matrix. Now, we have the next one, 0 matrix. So you can see 0 matrix. It contains 0 elements. Please take note. It doesn't contain non-elements. So 0 is an element of the matrix. So it contains 0 elements. So long 0 is in that bracket, so 0 is the element. So the fact that 0 is in that bracket doesn't mean the matrix is an empty matrix. No, it's not an empty matrix. It's a matrix that contains an element. So the elements there is 0. You can see all the elements there are 0. Now, diagonal matrix. So you look at it. There is what we call major diagonal, and there's what we call minor diagonal. There's what we call major diagonal, there's what we call minor diagonal. Now, your major diagonal is the is this example of diagonal matrix you can see on the screen. It's an example of your major diagonal. It's an example of your major diagonal. You can see 1, 2, 3 at that diagonal. So a diagonal matrix is a matrix who has its elements along its diagonal, while that elements means 0. A diagonal matrix is a matrix that has its elements along its diagonal. So you can see the only element we have there 1, 2, and that 1, 2, 3 is found along diagonal. So what's a minor diagonal? A minor diagonal is the other way around. So it's just like you are writing times. So if you write it like you're writing times, so major is the one you are seeing on the book now. The minor is the second what? Transversal, that crosses the transversal. So that's a diagonal matrix. So it can be like this or like this. It can be major or minor. Then scalar matrix. So you see, the difference between a scalar matrix is, okay, first of all, note, you will see that there is a relationship between a scalar and a diagonal matrix. So what's the relationship? A scalar has elements on its diagonal, but the elements are represented by what? 2. They're represented by 2, while other elements are 0. So a diagonal matrix on its diagonal is going to be having different elements, not unit elements, like different elements. It can be 4, 5, 6, it can be 2, 4, 8, it can be 6, 2, 9. But a scalar matrix just has on its diagonal 2 as the element. 2 as the element. And the next one, a unit matrix on its diagonal has 1 as the element. Has 1 as the element. 1 as the element. I believe you are taking note of that. Has 1 as the element. Now, upper and lower triangular matrix. So look at upper triangular matrix. See, it's a triangle. A triangle. You can see a triangle. So look at it. You see 1, 2, 3. If you trace it down, where you are, if you trace it down, now draw a triangle. From that point, draw a triangle. You will see that that's a triangle. So once you have drawn out the triangle, every other element remains what? 0. So that's why we have 0, 0, 0 at the top. So it's a triangular matrix. That's a triangular matrix. Triangular matrix. Triangular matrix. Triangle. See something like like see. So that's we cut out that shape. So you use that 1, 2, 3, 4, 5, 6 to cut out the triangular shape. You see, it's a triangle. Then other elements is what? 0. That's a triangular matrix. So that's upper triangular. So the other one, lower triangular. Lower triangular. It means the 0 element of lower triangular there, while the 0 element of upper triangular are at the top. So just try to use the idea I just gave you now. Trace those figures down. Use it to draw a triangle. You will see, cut out the triangular shape, then other elements remain 0. That is a triangular matrix. And remember we said matrix has wide application in engineering, computer, and etc. So it has its application in business as well. Remember, we are doing business mathematics. So matrix has its application in business as well. Stand. So okay, before we go to matrix, okay, yeah, let's continue. I would do that later. So matrix has application in business, and majorly its application can be found in a hierarchy of an organization. So let's look at this now. Said a matrix organization is a company structure where teams report to multiple leaders. The matrix design keeps open communication between teams and can help companies create more innovative products and services. Using this structure prevents teams from needing to realign every time a new project begins. The matrix organization, team members, whether remote or in-house, report to a project manager as well as their department head. The management structure can help the company create new services without realigning teams. So what we are simply talking about here is organization hierarchy. So you can see organization hierarchy, organization structure. So what is the structure of an organization? What the structure of an organization should be like? So a matrix is used to define an organizational structure. See application of matrix. You can see application matrix. So that's the application of matrix. So you now see a strong matrix from the general manager, the senior managers. Then you see under the first senior manager has sales manager direct reporting to the senior manager directly. Sales manager 2 and sales manager 1 reporting to the senior manager. Marketing manager 1, marketing manager 2 reporting to the other senior manager. Engineering manager 1, engineering manager 2 reporting to the third senior manager. You understand now? So this is a strong matrix. Look at this one, a weak matrix. General manager to functional manager. So now what there are, why this is called a weak is matrix should be that is either it's a senior manager and a functional manager together. So if you look at the balanced matrix, you see functional manager and senior manager together. But most organizations, you find more senior managers. So that's why you see in the strong matrix, we have senior managers. So the structure of this organization now is what? With the use of a matrix. So a matrix has been used to what? Create the structure at which this organization is going to be reporting their activities for the period for this day business administration. So that's a matrix structure. Now, when to use matrix, I have to take it very fast, not too fast as well, because we have to power up. So, like I said, the calculation is on the line, so watch it and we understand the calculation. So let's just run through what we have here. So when to use a matrix type organization, you can see when projects lead to complex products. When projects lead to complex products. So we want to produce something that will require complexity in the process. So we need a structure. You got it. We need a structure. So everybody needs to know, who am I going to be reporting to? Am I going to be reporting to? So that's it. When project leads to a complex project. When a complicated design calls for innovation with more timely completion. So when you have a target, you have to complete a task within a particular time, and it needs for you to be innovative. So at that time, you will need a structure, a structure. So a structure of reporting the administration. So when a diverse mix of skills is required that need constant updating and development. So you can see that is when to use matrix. So it's not like we just use matrix. So these are situations that warrants an organizational structure should be drawn. So we want to achieve a task now. So as the general manager of the organization, he or she has the overall power over everyone. So, but everybody cannot be reporting to the general manager. So the general manager must have those that will be reporting to him or her directly. So those that will be reporting to the general manager must have so those that will be reporting to them as well. So it makes delegation very easy, and it makes It gives room for more effectiveness and efficiency in completion of tasks. For advantages of matrix organization, see, allows efficient utilization of resources. Individual can be moved among projects. So what do we mean here? If this person is not performing well in this, we can decide to move him into the other project. If he's not performing well in this, you can decide to move into another. That's how. Provides a core of functional expertise, facilitates information flow. Team members can communicate with project and functional managers. So, matrix organization advantage and disadvantage. Disadvantages: battle between functional and product authorities, cost of team decision making, increase in potential influence cost. So what we are simply trying to say here is, okay, if you look at this one now, look at this, you see, from chief executive officer, sales division, service division. So the sales division, service division are found in the organization. Now, under the sales division, you have the business sales department, consumer sales department. Under the service division, business service department, consumer service department. So you understand. So that's just it. What I'm simply trying to say is that matrix has its application to different spheres of the academic. And as well, it has its application to business. So, and one of the application of matrix to business is what we are seeing, we can see that we are talking about it. It is the structure of organization. So we can read up on our own. Okay, let's just do one or two calculations so that we just move to the video. So now how to add, let's just do one or two on how to add and subtract matrix, addition and subtraction of matrix. Okay, now look on my screen now. So let us use that square matrix. So bring out that square matrix in your notes, everybody. 1, 3, 4, 5, 2, 4, 1, 9, 6. So bring it out in your notes. Plus, now I want to add it together now. So let's add it, that lower triangular matrix. Look at lower triangular matrix. 5, 8, 3, 0, 1, 2, 0, 0, 7. So let's say this the first one is A and the second one is what? B. First one is A and the second one is B. So let's do A plus B. How do we now? We are going to add and just when you are typing answer, just type your answer out. That's bracket. So we just do A plus B. So how do we add? Very simple way of adding. Take the first element of A and the first element of B. The first element of A is 1. The first element of B is 5. So 1 plus 5 will give you 6. Get that now? The next element of A is 3. The next element of A is 8. So 3 plus 8 will give you 11. The next element of A is 4. Next element of A is 3. 4 plus 3, 7. Move to the second one, second row. The next element is 5. The next element of B is 0. So 5 plus 0 is what? 5. Then this is 2. This is 1. So 2 plus 1 is what? 3. Then 4 plus 2 is 6. I guess we have gotten the way I'm doing it now. Then 1, 0. 1 plus 0, 1. 9, 0. 9 plus 0, 9. 6, 7. 6 plus 7, 13. That is A plus B. So now everybody do A minus B. But yeah, very quick. Let's not waste time. Just want to show us how to add and subtract. So everybody do A minus A minus. So you're still following the same order. The first element 1 and 5. That will be 1 minus 5. Yeah, let's do that first. And just type your answer to the chat. So I'm waiting. Yeah. waiting. A minus B. Let's do A minus B. Just type your answer, like you don't have to put it in the bracket. Just type it in order. So space it. Yeah, space it. Waiting. Okay. Zainab, how did you get 4 minus 8 minus 3? Zainab, review your work again. Review it again, Zainab. Review. Zainab, review it. Remember, you're taking it 1 and 1, like 1, 5, you're minusing. 3, 8, you're minusing. 4, 3, you're minusing. So review it again, Zainab. Yo. Waiting. Okay, Steven. Okay, Steven, you are on point, but you are missing some things. 1 minus 5 is supposed to give you minus, not 4. So when a small number is deducting a big number, your answer should be negative. So Steven, review that as well. The negative sign appropriately where they should be. Oh yeah, review that as well. Zainab, I'm waiting. Okay. Yeah, we are using the square matrix and the lower triangular matrix. So look at the square matrix 1, 3, 4, 5, 2, 4, 1, 9, 6. That's what we are using. And the lower triangular matrix 5, 8, 3, 0, 1, 2, and 0, 0, 7. So those are the two matrices we are simplifying. So that's it. Those are the two matrices we are simplifying. So let's quickly do justice to that. Okay, Steven, correct, correct. Zainab, waiting. Okay, just drop your answers. Drop your answers while we move on. There's really no much time in our part. So drop your answers, I will see it. So, we have talked about the organizational thing, the structure of organization in matrices I use. Great. So let's look at the next one, discounting. Now, when we were talking about the first topic for our break, I made mention of discounting. I differentiated it with compounding. So now you can see here now that I told you that if we project that in the future we are going to have a future cash inflow of 200,000. Like, pay attention. If we project that to embark in an investment, and in the first year of that investment, we are going to have a future cash inflow of 200,000. So what does discounting mean? So discounting means that this 200,000, we are what? Bringing it to present value. Present value. So we want to know how much is this 200,000 that is worth, like this 200,000 that we project to be a cash inflow in 5 years' time. How much is that 200,000 in the current year we are? That's discounting. Now I told you compounding has to do with accumulating interest to be able to attain a future sum of. But discounting has to do with bringing the future value to its current economic value. So we are bringing this 200,000 to the current value. So the discounting technique is usually calculated as 1 plus r raised to power minus n. That's the formula we use for calculating discounting technique. 1 plus r raised to power minus n. All right, everybody, let's do something together that we understand the concept of this discounting. Now, be with your notes and your calculator now. So we are going to do this together, everybody. So put years, 1, 2, 3, 4, 4 years now. So draw a table, like a line. So put cash, the next one, put cash inflow. Now, this cash inflow is future, they are future values, future sum. They are amounts I project that I want to realize in the future from any investment I am making currently now. So in the first year, put 300,000. In the second year, put 500,000. The third year, put 450,000. In the fourth year, put 600,000. In the first year, 300,000. Second year, 500,000. Third year, 40,000. Fourth year, 600,000. First year, 300,000. Second year, 500,000. Third year, 450,000. Fourth year, 600,000. Now, I want to discount these inflows now. So draw another line again. So once you have drawn another line, then write on the top, this discounting. Okay, just put DF. So DF means discounting factor. Remember, I told you the formula. So everybody writes the formula. I told you the formula for our discounting factor is 1 plus R. 1 plus R raised to power minus n. So everybody write the formula out. 1 plus R raised to power minus n. This discounting technique as well is an investment appraisal technique. So 1 plus R raised to power minus n. So this n be your number of years. Our n will be number of years. Now, R. So let's now assume that our interest rate is 12%. Oh yeah, our interest rate is 12%. So now we want to begin to discount each of these future cash inflow. Remember, I told you that discounting has to do with bringing in a future sum to its current economic value. So we want to know how much this 300,000 that we are going to generate in the first year of the investment, how much does it worth currently? So how do I go about it? The first thing I will do is write your formula. You see 1 plus R. So what is R? 12%, right? So 12% will give you 0.12, right? So raised to power minus 1. I recap. Bring your formula out. Just do the workings somewhere. So the brackets, 1 plus R. Remember, it's 1 plus R. So what is your R? 12%. Your R is 12%. So that 12%, if you divide it by 100, that will give you 0.12. Then raised to power minus 1. So 1 plus 0.12 will give you 1.12 raised to power minus 1. So let's find that value. So 1.12 raised to power minus 1. That will give you 0.8929. Now write it in 4 decimal places. We are all going to show our answers. When it's time for us to show our answer, I will let us know the answer we are showing. But just follow the step I'm giving us. So the first year, round it up to 4 decimal places. 4 decimal places. So I have 0.8929. So if you are not having 0.8929, maybe I'm missing it somewhere. Remember, I told you, open your brackets. Formula is 1 plus r, then raised to power minus n. So just press it in your calculator. What's your r? R is 12%, right? Which is 0.12. So 0.12 plus 1 will give you 1.12. So just work with 1.12 raised to power minus n. So it means the n, you will now be changing it after 1, 2, 3. Good. So yeah, let's do that fast. So let's do for the second year. 4 decimal places. If it needs you to round it off, but 4 decimal places. I want to believe we are working. Okay. All right. On my own end, I'm done up to the 4th year. So I've discounted the number of years to my present value now. I've done that. So let's get the total. So after I have discounted them, after I have discounted those number of years now, to believe we have done that. After you have discounted it, then rule another line again, then put present value. Put present value, present value. So how do you get your present value? So you multiply your cash in by your discounted factor. Cash inflow by your discounted factor. The cash inflow by your discounted factor. So the one for the first year, multiply cash inflow by discounted factor and put your answer. So if you're already writing your answer. All right, so having done that, so this is how you're going to bring your answer out for me now, everybody. So just type year 1, your present value. It is the present value you're bringing out for me now. Year 1, present value. Year 2, present value. Year 3, your answer. Year 4, your answer. Yeah, let's do that fast. I'm waiting. So what's year 1 value? The present value for year 1, present value for year 2, present value for year 3, present value for year 4. Let's do that fast. Let's do that fast. Let's do that fast. Let's do that fast. Present value for year 1, present value for year 2, present value for year 3, present value for year 4. Oh yeah, I'm waiting. Yeah, I'm waiting. I'm waiting. So present value for year 1, present value for year 2, present value for year 3, present value for year 4. Okay, Stephen. Okay, Stephen, what you gave me was the discounted factor. Hmm? What you gave me is the discounted factor. So it is at this discount we are going to, it is at this value we are going to discount 300,000. So what I'm asking you to do now is for that first year now, multiply 0.8929 by 300,000. What's the value? That value you will get is your present value. So try and adjust this now. Try and adjust it. Try and adjust it. Adjust it. So multiply the this year one discounted technique by the cash inflow of year one to get the present value of year one. Then the one for year two multiply by cash inflow of year two to get the present value for year two. The one for year three multiply by the cash inflow of year three to get the present value for year three. And the one for year four multiply by the cash inflow for year four and get the present value for year four. So I'm waiting. Waiting. I just want to show us how to discount. In earlier classes, we did how to compound. So we already know how to compound a sum of money. So it's important we know how to discount a sum of money to present value. So that's what I'm trying to show us now. How to discount a sum of money to present value. Waiting. So Steve, just quickly finish it up. Michael, I mean, David, Stephen. Okay, Stephen is responding. Bala, Salman. I'm waiting. So once you have compiled it, just put it. I'm waiting. Okay. All right, Stephen. Very correct. Very correct. Very correct. Very correct. So so it means that so what we are doing here now is that if we project that in an investment, our first year cash in, when you make an investment, there will be inflows every year that you are going to be receiving. So now, our first year cash inflow, if we project that it's going to amount to 300,000, then, so it means that 300,000 now is 267,870. See now, that's 200,000. That 300,000, that's the cash inflow will amount to in the first year of the investment. What is 267,817 naira now? So that is discounting. So on your own, do something on your own. What you're going to do is reduce the interest rate. The interest rate here we have is 12%. So reduce the interest rates and monitor your present value. You are going to see what is going to happen. I won't tell you, but you have done this one. Reduce the interest rate later when you are done with the class on your own. Then monitor your present value. You can reduce it to like 10%. After 10%, you can reduce it to like 7%. You can reduce it to like 5%. And this is like 3%. Just try and reduce the interest rate maybe like 5 more times or 4 more times. Then monitor the present value. So you are going to see whether as you reduce the interest rate, whether the present value will be increasing or reducing. So that is basically what discounting is all about. But like I said, main topic where we are going to be needing discounting is investment appraisal, and we are not going to be this semester. So now you see, in order to grow any business, every company follows the discount technique. So discount technique is an investment appraisal technique. What does it mean to appraise an investment? To appraise an investment means to test the viability, to test whether that investment is worth embarking on. Because an investment has to do with you going to put your money there and you are going to be getting returns from it. So we want to test whether that investment is worth embarking on. Whether if I put my money in that investment, whether I will get the right returns on the investment. So we are going to be dealing with that later on, probably next semester. So business follows the discount techniques in order to grow their business. All right, so we can read more on discounting technique. So you can see discounting cash flow formula. These are this one we start solving fully. When we start solving fully, we use it. So keep the materials. We use it when we start solving fully on investment appraisal. The types of discounting technique in business. So we can read all these ones on our own. We already know what concept of discounting rather. Can read all these ones on our own. So discounting is the process of determining the present value of a future payment or streams of payments. I already said that. A dollar is always worth more today than it would worth tomorrow, according to the concept of time value of money. So we are trying to summarize everything we have done so far. A higher discount indicates greater level of risk associated with an investment. So you look at what we just did now. This number 3 is talking about what we just did. You know, I told you to go and reduce your interest rate. So let me just tell you, as you are reducing your interest rates, your present value will be increasing. So it means that when your interest rate is high, you stand greater risk than investment. So a higher discount indicates a greater level of risk associated with an investment. So remember, investment is a risk. Yeah. So the higher the interest rate, the higher the risk you are taking. Do you understand? So an asset has no real value unless it can produce future cash flows. So the essence of keeping an asset in a business for you to generate big benefit, future resources to the business. So there is no point, there is no value in an asset when it's not achieving its number one objectives, and which is what? Produce future economic benefit. So that's basically that on counting. You can read all these on our own. I've given us what we need to know majorly. So let's quickly run to okay. Now utilities and logarithm. Let's just do one or two things on it. What's it about indices? Now indices is actually the plural form of index. And index means exponents. Index means exponents. So what you call raised to power. So if I say 2 raised to power, 2 raised to power, so that's powerful. It's called what? Index or what? Exponent. So indices is the plural form of indices is the plural form. 2 raised to power 4, that power 4 is the index, or you call it exponent. So what indices is basically all about is indices helps to be able to solve values of this form. Okay, now let's look at it. If I have 2 raised to power 4 times 2 raised to power 2. Now, without applying law of indices, without me applying law of indices, I want to solve this. What I would have just done is what? I'll just say 2 raised to power 4, that's 2 in 4 places. 2 in 4 places. That's 2 times 2. That's 2 in 4 places. Then times 2 raised to power 2. 2 in 2 places. 2 times 2. If I multiply everything together, 4, 8 times 2 times 2, 32 times 64. 2 raised to power 4 times 2 raised to power 2 gave me what? 64. But when the first law of indices will come, the first law of indices says that, look at it, first law of indices, where is it? Okay, so look at the first law of indices now. Applying the first law of indices, you see, a raised to power p multiplied by a raised to power q will give us what? A raised to power p plus q, right? So the rule is that the base must be the same. The base must be the same. So a is the base. So here, in my question, 2 raised to power 4 multiplied by 2 raised to power 2, my base is 2. And 2 are the same. So if I'm going to apply this to the law of indices, all I just say is, since my base are the same, just 2 raised to power 4 plus 2. My multiplication becomes addition. That will be 2 raised to power 6, and that will give me 64. So you can see how law of indices made it more easy to simplify. So the same thing is the other one. Division changes to minus. Division changes to minus. You can see the illustration there. 10 raised to power 4 divided by 10 raised to power 2. Take note, the basis must be the same. The basis must be the same. So the base is 10. You pick one of the base, then the power 4 minus 2. So division changes to what? Minus. So 4 minus 2 will give you what? 2. So your answer is 10 raised to power 2 or 100. Then another law of indices is the law that says anything raised to power 0 is 1. Anything raised to power 0 is 1. Yeah. Anything raised to power 0 is 1. Anything raised to power 0 is 1. That's what the law says. Anything raised to power 0 is 1. So long as it's a constant raised to power 0, it is what? 1. Now, this is a negative power rule. It says a raised to power minus p. A raised to power minus p is equal to, now, that power minus, the other way around is called reciprocal or inverse. Reciprocal or inverse. So the inverse of power minus becomes 1 over. The inverse of power minus, power negative. So whenever you have anything raised to power negative, the inverse or the reciprocal is usually 1 over. So that's why I'm saying 1 over a raised to power p. So you see the illustration, 5 raised to power minus 1, that will become 1 over 5 raised to power 1. 8 raised to power minus 3, that will become 1 over 8 raised to power 3. So this is as a result of ability to be able to express numbers in a more simpler form than for us to be simplifying it step by step. And this has made it more easier. So you can see the next law. See the next one. A raised to power p into bracket q. So mathematically, anything in the bracket means multiplication. The two powers are multiplying themselves. That is a raised to power pq. A raised to power pq. A raised to power pq. You can see that. A raised to power pq. That's a raised to power pq. Coming. So you see, next one, a raised to power p multiplied by b raised to power p. So you can see, this time around now is the other way around. The bases are not the same, but the powers are the same. This one, the bases are the same, the powers are different. So multiplication changes to what? Addition. But here now, the bases are not the same, the powers are the same. So you multiply your base, then you pick one of the power. Multiply your base, you pick one of the power. So everybody take this question and give me the answer very quick. There are many illustrations there. We move forward and study them on our own. Really not time. Everybody take this question and give me the answer very quick. Number one, 3 raised to power 2 times 3 raised to power 6. So just give us 5 questions. Number one, 3 raised to power 2 times 3 raised to power 6. That's number one. 3 raised to power 2 times 3 raised to power 6. Number two, 4 raised to power 5 times 4 raised to power 7. 4 raised to power 5. Sorry, 4 raised to power 5 divided by 4 raised to power 7. 4 raised to power 5 divided by 4 raised to power 7. Number one is 3 raised to power 2 times 3 raised to power 6. Number two is 4 raised to power 5 divided by 4 raised to power 7. Number three is 7 raised to power minus 2. Number three is 7 raised to power minus 2. Number three is 7 raised to power minus 2. Number four, open your bracket, 4 raised to power 2, then close your bracket. Open your bracket, 4 raised to power 2, close your bracket, raised to power 5. Open your bracket, 4 raised to power 2, then close your bracket, raised to power 5. Then, number 5, 2 raised to power 4 times 3 raised to power 4. 2 raised to power 4 times 3 raised to power 4. Then, okay, so that's all. Oh, yeah, please, let's quickly give me the answer. Everybody, very quick. Very quick. Next 120 seconds. In the next 120 seconds, for those that are still online. So next 120 seconds, let's quickly give the answer. Salman, Bala, Stephen, Aminu, Michael, David. Oh yeah, very quick. Let's give the answer very fast. Let's give the answer very fast. So other things we need, the slide has made for you. There are many illustrations there. We just need to look at it on our own understanding. But the basics is what I have just given us. Basics is what I have just given us. Okay. Oh, the question again. Number one, 3 raised to power 2 times 3 raised to power 6. Number one, 3 raised to power 2 times 3 raised to power 6. Number two, 4 raised to power 5 divided by 4 raised to power 7. Number two, 4 raised to power 5 divided by 4 raised to power 7. Number three, 7 raised to power minus 2. 7 raised to power minus 2. Number four, open your brackets, 4 raised to power 2, then close your bracket, power 5. Open your bracket, 4 raised to power 2, then close your bracket, power 5. Then number 5, 2 raised to power times 3 raised to power 4. 2 raised to power times 3 raised to power 4. So let's get the answer very quick. Okay. 1. Steven, number 1 is 3 raised to power 8, not power 9. Number 2 is correct. Number 3 is 1 over 7 raised to power 2. Look at it. Look at the law again. I said it here. Look at it. See this one, the next one. See, 5 raised to power minus 1, that is equal to 1 over 5 raised to power 1. 8 raised to the power minus 3, 1 over 8 raised to the power 3. Do you understand? So that power minus is changing to 1 over. The power minus is changing to 1 over. So correct number 3. Stephen, correct number 3. Number 4. Now, Stephen, you have to correct number 4 again. Number 4. This one, the first one, you can see a raised to the power p into bracket q. So you see that p and q are multiplying themselves. They are not adding. P and Q are multiplying themselves. They are not adding. So correct number 3 and number 4. Then number 1 is supposed to be 3 raised to the power 8. So Stephen is quickly correct that. Michael Adebisi. Okay. Okay. All right. Stephen, please correct yours. Stellman, you asked for the question again, and I'm not seeing anything. So basically, we can't really do much again. Indices, we have logarithm. There's really no much time my side because we are already approaching the end of the class. But indices and logarithm, they are kind of brothers. So they are just similar. Understand? In indices, you see indices. This is a rule. Now let us look at logarithm. Logarithm. In logarithm, that rule in indices is the other way in logarithm. So in indices, you have a raised to the power m times a raised to the power n will give you a raised to the power m plus n, right? But in logarithm, you have log a base 10 plus log b base 10. That becomes log a times b base 10. So we can see they are the other way around. Indices is the other way around. There's really no much time to actually delve into it. Get so you can see a question on simple interest, or yeah, deposit money grows double in 6 years in the bank at the interest rate of I. Find the value of I. You can see application of logarithm. So application of logarithm. Okay, Salman, number 1 good, number 2. Number 3, Salman. No. Salman, number 3, number 5 is correct. Number 3 is supposed to be 1. Okay, number 3 is correct. That means number 2 is what you know, right? And number 4. So number 2 is supposed to be 4 raised to the power minus 2. Number 2 is supposed to be 4 raised to the power minus 2. Number 2 is supposed to be 4 raised to the power. So you can see the application of logarithm to business. So it has its application to business, like I said every time. Then vector refers to an object that has both direction and the magnitude. This is there's a video under it to watch examples of vector, velocity, force, momentum, wind, and so forth. So these are basic terminologies in vector we should know. So well, we don't have much time to really go in depth, and but I want to believe that to touch um I want to believe that the to able to at least put it into practice when we come across questions and when we face these life challenges. So thanks, welcome. So at this juncture, I thank you for having me around, and it's my pleasure to be one of the tutors, and I pray that and hope that gets to greater heights. Thank you very much. It's been a very, very productive day. It's what I love doing best. So when I find myself, it's my all. Thank you very much. Have a wonderful day ahead. Bye.
All right, Omobolaji, thank you so much for that. Okay, I don't know if anyone has a question to ask you. Please, if you have a question, do well to ask. Okay, it seems you don't have any question. All right. Okay. People are telling you thank you. All right. Thank you, Aminu. Okay, so everybody, it's going to be a very productive weekend. All right. Please do well to study your materials. If you are yet to subscribe to our YouTube channel, please do so you can, and then turn on your notification bell so you can be getting information whenever we post them. Please, if you are yet to pay your acceptance fee, do so. We are already in the middle of the semester. You were supposed to do so even before you start your study, okay? And then regarding your test, I'm going to reiterate again. Once we announce a test for a particular day, do well to write your test on that very day. Please take it very serious so it will not affect your results at the end of your studies. All right. Okay. If there is any other announcement, you will hear it on the group. All right. Bye for now and do have a beautiful weekend.